Thanks everyone for joining. This is like the first workshop we had prepared for this hackathon. We plan to do at least one event like this every week until the hackathon ends. As a starting point, I thought it would be good to start with an introduction to Conflux and specifically Conflux development. The goals for today's call is there is two of them. One is that you can learn all the basics, all you need to know to get started with Conflux and what Conflux is and what the main differences are between Conflux and other blockchain networks. And then we will move to a hands-on demo with a minimal contract deployment and front-end integration. This is like the four key stuff you need to know like to get started with Conflux on understanding what Conflux is. The tree graph is the main like innovation Conflux has developed, which is basically embedded in the way the ledger is structured, like the way data is structured in the blockchain. Then the second key element is the gas selection rule, which is also an innovation compared to the ghost selection rule, which was original from Ethereum. The other difference is that it has a hybrid like consensus mechanism, which includes both proof of work and proof of stake. And finally, there is the different spaces feature, which is originally it had only core space, but after some time there is also the E space, which is 100% compatible with Ethereum virtual machine. So let's go into these four elements in a little bit more depth. The tree graph is the key innovation that enables Conflux to process transactions in parallel, like in enhancing the throughput and the scalability of the chain, basically. This is what we would say the main innovation in Conflux and what enables it to be what it is. And yeah, the main difference is that there is a parent edges, referent edges, and each block is related to a parent edge and other reference edges. So there is many blocks in the same epoch, basically. So there is different transactions that can be all combined into the same epoch, which also reduces the conflicts among the different blocks proposed by miners. This is like a graphic representation of the tree graph, but if you are interested like in cryptography and the understanding like the key innovation on Conflux, this is where you should start with. Then we have the cast selection rule, which I mentioned. Here the main difference you need to understand is that they changed the greatest heaviest observed subtree, which exists in Ethereum, for an adaptive subtree. And this enables Conflux to prevent liveness attacks. Basically, it protects it from liveness attacks by changing dynamically the weights of the blocks, making there different types of blocks, normal blocks and special blocks, which have different weights. And this basically is a feature also developed by Conflux that differentiates Conflux from other chains, basically. Then there is the spaces, core space, which is the original chain, which is pretty much similar to Ethereum virtual machine, but has different address notations. For example, they start with CFX instead of like 0x, like as an Ethereum address for contracts or wallets. So there is some differences, but they all support Solidity as well. All smart contracts are developed in Solidity for core space as well, and it's faster than ESpace. Basically, it's twice faster. The block time in ESpace is twice as core, and it has another difference, which is the gas sponsorship feature, which allows the developers to sponsor the gas for users of their smart contracts, so they don't need to pay gas. It can be like for token or gasless tokens or contracts that doesn't require you to pay to interact with them. So this is also a key innovation on Conflux, which it's I think pretty much aligned with account abstraction. And yet then there is ESpace, which was launched after CoreSpace, and it's basically a virtualized Ethereum chain on Conflux, and it's fully EVM compatible. Now with the latest hard fork, all the latest updates that took place on Ethereum were also implemented on Conflux. So it's pretty much the same experience as developing on Ethereum. And this is great for adoption, especially from developers who can migrate their contracts and their applications very easily to Conflux by just using ESpace. And these two spaces are logically independent. They both have like different transactions, different contracts, and different blockchain explorers, different RPC endpoints. Oh, sorry, RPCs are usually the same. Then there is the cross-space call. The cross-space calls is an internal contract that enables the communication between the two spaces. Basically, you can send CFX or send messages from one space to the other, and it's embedded like in Conflux, the chain itself. So this is what you need to know about spaces. If you are an Ethereum developer, I would suggest you get started with ESpace first. But for this hackathon, there is no specific requirement. You can choose whatever space you want. We might encourage you to use ESpace just because it's easier, because there is a short time to build. And there is a lot of tools from Ethereum that you can also use on ESpace, because CoreSpace also has different SDKs and different tooling available. So there is more tooling for ESpace because it can leverage all the tooling existing for EVM compatible blockchains. Yeah, that's basically all the basics you need to know about the spaces. Then we have consensus mechanisms. And yeah, the proof of work is actually the main consensus mechanism. And originally Conflux, it was proof of work only. Probably you all know what proof of work is, but basically miners solve by brute force, try to solve mathematical puzzles like to validate transactions and add new blocks, and they propose blocks with transactions on them. And here is where the clear graph algorithm and the gas rule come into place, like in the way blocks and transactions get selected and how they are organized in the ledger structure. And after some time of Conflux existing as proof of work only, the proof of stake layer was added, like on top of proof of work, which has a proof of stake finality. And this basically is like an additional security measure. Like it's not like the core consensus part, but an additional security measure, basically planned to resist potential 51% attacks. So because any blockchain, when they start, they usually have a few nodes, and they are more likely like to get attacked, or there are more chances like for attackers to attack them. So the proof of stake layer added that additional security layer, and it also improved the confirmation times. So to get started on Conflux, these are the three key requirements. Let's say you need to have a wallet, which you can use Fluent for both ESpace and CoreSpace. But then for ESpace, you can use like any most EVM compatible wallets like MetaMask or Ravi, which are the most popular. I personally like Ravi a lot more than MetaMask. But then also you can use Ledger, of course. You can use Ledger on both Core and ESpace. For ESpace, you just need to use the Ethereum application on Ledger, and for Core, you need to use the specific Core app in Ledger, which is on the store. And then for RPCs, these are the examples for the RPCs for Conflux ESpace, both mainnet and testnet. And then there is the RPCs for Core Space as well. And here you can also use your own local chain, which you can run locally, or your own node as an RPC provider. Usually to start building, you use testnet, and then you can just use public nodes on mainnet. And then, of course, you need some CFX, which can be obtained from the faucets. There is a ESpace faucet, a Core Space faucet, and then there is a mainnet faucet, which supports both Core and ESpace. Then for developer tools, here we will focus more on ESpace because it's where the most tools are. But basically, there is the key tools like for smart contract development, like Hardhat Foundry. You can also use Remix IDE, which is a web-based app. Yeah, I personally like Hardhat a lot, but that's totally up to you which framework to use at the moment of developing smart contracts. Then there is other tools like ThirWeb, which offers like a custom templates for front ends or for smart contracts that you can also easily deploy on ESpace. And Cookbook also is a library of smart contracts. Here is also missing like Open Zeppelin, which of course can be used. There is lots of audited contracts there that always encourage people to use those standards, like for building and prevent like building stuff from scratch always. So these are key resources for any smart contract developer. Then there is other tools like Privy, for example, for what it would be like a account abstraction where with social login, or Layer 0 for cross-chain implementation of tokens or DeFi protocols. Then we have Pyth for oracles, and the graph also. You can run your own the graph node and use it for indexing. Apart from that, there is also all the EVM development libraries and SDKs. Here there is a huge amount, but for example, for frontend, you have like WAGMI, VM. There is the Web3.js, Web3 PY for Python. Well, there is lots of different libraries, and there is also libraries that you can leverage, like for example, the Uniswap libraries or SDKs, which are also good to interact, like for example, with Ginseng Swap, which is a Uniswap v3 fork. So the contracts are the same, and you can use the same SDK you can use on Uniswap to interact with Ginseng Swap, for example. And then there is a new tool here that yesterday it was announced that they are supporting Conflux, and they are Cloud Studios, who are also sponsoring this hackathon. I haven't tried it yet, but I encourage you all to give a look. But they offer a lot of different toolings for development. Okay, then we have some development resources. First of all, we have the documentation site, which is the main like source of documentation we provide, which covers like everything, all the general stuff, the stuff specific for Conflux Core, and the stuff specific for Conflux ESpace. And there is a lot of like tutorials and information there. There is also the YouTube videos. We have a huge library of videos, and there is also a link on the web on the documentation site with a list of videos with tutorials that you can use to get started. And then there is different like templates and open source project repositories that you can use, like the Conflux Scaffold or Conflux Dev Kit, which has lots of different templates and projects that you can use to get started. Those are key for like a hackathon in which you have like a small amount of time, and this can help you a lot to get started like very fast. Finally, just a quick review over the development process. Like it's very important for you guys to research, design, plan, document. In this hackathon specifically, we will also check the documentation and how you like explain what your project is about and how to use it. Those are key elements from for the development process in general. Same as testing. It's very common that people overlook testing, but especially today with all the AI assistant tools, testing can help a lot because they can be kind of automated and provide a lot of insight on how your project works and on all the features you have. And yeah, overall the process is basically you need to start researching, planning, designing. Probably for the hackathon, if you haven't chosen an idea, you should choose it like right now and start like doing some research on how to implement the idea, and then design the solution or the project you want to build, and plan how to build it, and start building all the documentation like even before building the project. And then probably you can build smart contracts. It's not required to deploy smart contracts for the hackathon, but at least you need to have a front end that interacts with Conflux. So I would say the front end would be like an essential, but it all depends on your application. It can be also like a Telegram bot, which doesn't actually require a front end. But yeah, the key requirement for the hackathon is that it uses Conflux. No matter if it is ESpace or Conflux Core, that's up to you. There is also no limitation, so you can build wherever you want. I always encourage people like to build stuff they would actually use themselves and they would see value in. So that's a good way to choose an idea. Okay, now let's go to the hands-on demo. Just for simplicity, I will use GitHub code spaces, and I will show you one of the Conflux dev kit templates, the full stack one. So this is the dev kit. I think SP here is here in the code. He built this set of repositories. So thank you, SP, for this. And if you have any questions, you can contact him and ask him. But there is a lot of different repositories with starter kits or boilerplates or templates, whatever you want to call them. But today we will use the full stack template, which includes both like includes the node capability, includes the hard hat development part and the front end part. But there is a lot here that you can also check out and see how you can use them on your projects. So I have forked the repository and I will just use GitHub code spaces to have like an empty environment. So you can see there is two packages in the project structure. There is the front end and the hard hat for ESpace. We will try to deploy a contract on ESpace and build the front end that can interact with the contract. Well, here is all the instructions. Here, let's start with the devkit commands because all of this started with the devkit, which is basically a tool that allows you to run your own Conflux chain locally, basically, apart from a lot of different stuff. But it has a CLI tool, which we will use now. And for the wallet management, we will generate a new wallet uh, using the devkit. And I will also show you how like you can run a node and everything else. So first we will use this command, which is devkit wallet add. So you can encrypt it or not. You can generate a new seed or you can insert your own seed. Here we create a new one. Over there we have set a wallet. Now we should be able to see the address. Here is the address. In general, you should like use this address to get some faucet, so some CFX from the faucet. But I have already done that today, so I won't be able to do. This is like for starting like everything, including like a node. We will skip that part and just move to the deployment of smart contracts. Basically, you have your hard hat project with the config. This is the key thing you need like to be able to use hard hat on Conflux, which basically includes everything like all the URLs for the RPCs for each chain. You have like Conflux ESpace, the ESpace testnet, and the local chain, and then some like other information for the Explorer part. So with this configuration, you have everything you need like to deploy contracts. Let me create a new terminal. Okay, now it worked. Now we should be able to deploy. Okay, now it's deploying the contracts to Conflux ESpace testnet. Took some time, but got it. So now after doing that, we should be able to generate the ABI and then, so here is the new contracts. Let's check Conflux Scan Explorer. But in the same way, you can also verify contract or of course, deploy your own custom contracts. In the meanwhile, I will generate the ABI, which should now change from 0 to the actual addresses. Yeah. And yeah, here is the contract we just deployed. And for the front end part, basically, well, after that, you just run the front end and it already has like a full connection and easy interaction with the contracts. So this is an example of the tools that you can use. Then we need to make this public and access front end. But you can see that it's like a very simple like front end in which you can choose the chain, switch between ESpace, ESpace testnet, and the local chain. And there is the tool like to connect the wallet. can see there is actually 4 different contracts. We should be able to interact with all of them. Here you can see it's loading the information like the owner, which is the wallet we just generated using the dev kit. Then there is all the contracts information. Let's try increment here and interact. You can see like this front end has already like all the information, like all the code required to interact with Conflux, like out of the box. I haven't coded anything, just run the commands and yeah, you can see count now says 1, and yeah, it's basically working. And already like detecting my wallets, and I can also change the network. All of this is out of the box from the dev kit, so great thanks there to SP who built this, and yeah, he built this and a lot of different stuff. And so thanks, and that's basically the example I had like for the demo, the on-hand demo for today. This is just an example, and the same way that I did this, there is like lots of different tools, like the private starter with the Next.js app. There is only a hard hat for space template. There is a core template. There is connectors like for Gecko Terminal, the Filama, like to get some information, and there is even like an ELISA like template that also connects with Conflux. ELISA is an AI agents framework that if you are building agents, it's a very cool way to get started as well. This is like a quick overview of what Calp offers. I have just created an account but haven't really tested. I'm not sure if Conflux is already integrated or was it going to be integrated today, but they are supporting Conflux pretty soon if they are not yet supporting it. So this is also something you should take a look at. And yeah, here is the library of videos I mentioned also, with lots of different videos made by our Devrel Matt. And yeah, uh, basically that's all I had for today. Thanks everyone for joining today. I hope you are enjoying building on Conflux, and just let me know if you can, if you need any help. We will be there on the Discord channel or the Telegram group, and feel free like to ask your questions or DM us for any support. So thanks everyone for joining and for participating in the hackathon, and yeah, just keep on building.